Ichang, Skiljada Hinudi ang Hade Wadlawane Sao Slangulang. So good day, everybody. We are at SGaan Kinghlas, and my name is Skiljada, and I work for the Council of the Haida Nation. I'm the marine biologist / planner for the marine planning program. And we're all really excited to be at SGaan Kinghlas today. We're serving the east side of the Seamount. So we're pretty far west of my home in Old Masset. And right now we have an ROV currently below 1,000 meters down at SGaan Kinghlas, and we're taking videos, live streaming the videos, and we're comparing it to monitoring we did 4 years ago that Jasal Jus Yakujanas from Old Masset was a part of to represent CHN, as well as our many other partners involved. And we're comparing the health of these ecosystems. They're really bursting with life. There's lots of different critters down there, sea stars and brittle stars, which are like skinnier starfish, lots of different fish and anemones and that kind of thing. Yeah, we're doing lots of different water sampling and that kind of thing that we'll tell you more about. So I think with that, I'll pass it off to Tammy. How for joining us today.
Hi, everyone. My name is Tammy Norgard, and I work for the Department of Fisheries and Oceans. I am the lead for the Integrated Conservation Monitoring Program. And really what I get to do is I get to help coordinate all the marine surveys that go out to help us collect data on marine conservation areas. So those are areas that are really special. We find that are very significant, and we want to protect them. And so, lucky for me, I get to help set up this amazing survey on this ship, and we're out here doing our deep sea marine conservation project. So this is where we get to go to deep, dark waters. And hopefully you have been able to look at our live stream. And if you do, you get to see that we have, right now, we have right below us, 1 kilometer down, we have our remotely operated vehicle. And it's down there lighting up the bottom of the ocean where there usually is no light. And we are setting up 10 meter by 10 meter squares, which we're going to monitor over the next many years to make sure that the health of this amazing ecosystem stays healthy, and we can actually then track the changes over time. So what we've decided to do this time is to just walk you through the ship. But instead of walking you through the ship, because there's a lot of activity going on right now, we decided to just show you the ship through a slideshow. So I'm hoping you guys can all see this. So this is the ship we're on right now. And what's really quite amazing with this ship is that it's 70 meters long, and we are in the middle of the ocean and we're talking to you guys. And so if you can spot on the ship how we can do that, it's the golf ball right at the very top. So that's how we're pulling this off. So Monica, do you want us to start our sort of slideshow and have everybody talk about their roles?
Sorry, you'd think by now I'd be used to Zoom, but I just keep the lips moving and I don't unmute. Yes, if you could please tell us about that, and then it would be great to hear the science you're investigating, and then we can also explore the cultural connection as well.
Okay, great. Thanks, Monica. All right, so as I mentioned, this is the JP Tully. It's a very large ship, and this there's lots of things happening on the back deck of the ship, and we'll show you all the bits and pieces in Zoom in closer detail. But yes, the golf ball is how we can talk to you. That's our satellite dome. So a lot of planning goes into a survey like this. As Monica has mentioned, we have many partners involved, and all of the partners have gotten together to select what we can do in the 2-week window that we have out here, which it's a very big ocean, and we only can do a tiny little bit of it every time we come out. So this is Dr. Charisse Dupree and Chelsea Stanley working out the plan. And this is our map of where we're going. I think that map was shown earlier, but this is the fun one we have, where we have lots of sticky notes and whales and seagulls involved, and we're just having a lot of fun with it. So I'm going to pass this off to one of our oceanographers, and Chelsea's going to talk about it.
Thank you. My name is Chelsea Stanley, and I work for Department of Fisheries and Oceans. I'm out leading the oceanographic program. So a big question that we have to answer when we're out here looking at all these animals on the bottom is, what kind of water do they live in? So just like when your mom checks your bath water before you have a bath, we need to know what kind of conditions these animals are experiencing when they touch the water. So I send down this piece of equipment here. It's called a rosette. So on the bottom of the rosette here, there's like a big thermometer. So this thing electronically measures the temperature, how salty the water is, how much oxygen the water has in it, what kind of nutrients are in the water. And all of the animals that we're looking at are basically bathing in this water all the time. So it's important for us to understand the conditions that they're living in. And then we also use these big bottles here. There's 24 of them, and they each hold 10 liters of water. And basically, when I send that rosette down and it gets down to 2,000 meters from the ship, I tell that bottle to close, and it captures that water from 2,000 meters in there. And then we bring it to the surface, and then we collect it. And we can tell from that water from 2,000 meters down in the ocean, we can tell exactly how much oxygen is in it, if there's any type of phytoplankton in it. Lots of interesting things come from the rosette. So that's why oceanography is important to our mission. And we are going to pass it over to Merlin.
Thanks. Hi. I'm Merlin Best. I'm a biologist with the Department of Fisheries and Oceans. Oh, you might want to see this. So I run the Taxonomy Lab here on board, and that means that I study the critters that we see in the video. So the corals and sponges and sea stars. Sometimes we get to bring them up on board with this special ROV that we have, so we can pick up one and bring it back here to the lab. So that's me with one of our special pieces of camera equipment, and we'll try to photograph everything and sort them and try to figure out what they are and kind of how many of them are down there, and so we can get a better idea of what these ecosystems look like. So here's an example of a photo. That's a squat lobster that we picked up with the suction sampler on the ROV. And yeah, I'll hand it over to Tammy.
Hi, everyone. So Georgia, who is busy right now, she's outside helping the ROVs collect all the data we need to build underwater 3D models. So what we're doing is very detailed back and forth, driving the camera back and forth, taking pictures. And then we're going to put all these pictures together like a puzzle, but a 3D puzzle. And this next picture is kind of hard to show, but this is a 3D model of an area. So we can go back and we can look at this particular sponge or this particular sponge and see how that one's changing and growing over time. So that's what Georgia's doing right now. So I'm acting for Georgia in this presentation. So I'm going to pass this off to, this is going to go to Chelsea.
All right, I'm back. So another awesome thing that we're doing on this survey is we are going to be mapping the seafloor using sound. So if any of you have ever learned about dolphins, you might know that dolphins send out clicks into the water that bounce off of fish and other prey so that they can hunt. Well, we're kind of doing the same thing. So this big red jelly bean looking thing there is called a multi-beam. And basically this big head sends down a whole bunch of clicks down to the bottom of the ocean. And those clicks bounce back off the bottom and then they're received. And basically this thing then turns them into an image that shows us exactly what the bottom looks like. Just like George is making 3D images of photos, we're making 3D images of the sound that's reflected back off of the bottom of the ocean. Oh, swiping the TV instead of the, and here's we go. This is us. We have a giant pole on the side of the ship and it's dropping the jelly bean down into the ocean. And then once it's down there, we start sending signals down into the water and our computers up on the ship interpret those signals and they show us what the bottom looks like three-dimensionally. There it goes. You can see that man there. He's the boss. He's the boss of the deck. That's our bosun.
Do you ever call it the
So
jelly
it takes
beam?
a lot of work to get all this done. Well, we were actually have been calling it the sea pig, which is quite cute because we got one yesterday in our sampling. So but it does look more like a jelly bean than a sea pig. So maybe we'll call it that now. All right. And next up is Daniel.
Thank you. So my name is Daniel. I'm a graduate student from the University of Victoria, and I'm helping out with the oceanography. More specifically, I'm going to be looking at using these bongo nets here to study the plankton that are hanging around in the water column. So these are all the little animals and little critters that float around in the water and are a lot of the food sources for a lot of different fish species, especially the fish that we like to eat, like salmon and all those. So what we do with these bongo nets is we'll put them down into the water, deep into the water, about 250 meters normally, and then we'll drag them back up to the top. And when they're dragged up to the top, then animals are caught within these two nets, and they get funneled into the ends where they're collected into little end pieces called cod ends. And then we can take those out, we can take them into the lab and study what little critters live in the water column. And we can count them all up, we can see what they're made of and do any number of tests on them. All right, and this is particularly important because they are a good indicator of a lot of different parts of the ocean and how healthy the ocean is. And also they will help indicate how the fish species will actually do in the following years, and if they're a good source of food for all the fish living in the waters. Yeah. All right, and passing it off to Tammy.
Hi everyone, I'm back again. So this is where Shrees would jump in, but Shrees is also working with Georgia inside the van on the deck, operating this camera. So there's a team of 4 people, which I'll get into that room. I'll show you that room in a minute, but this is the camera. Meet our Odysseus ROV. So on the front of the ROV, we have this, we call it the porch, and it's pulled out right now. And on the porch here, we have, these are cannonballs with markers, and these markers right now, there's one, to watch the live stream on the bottom of the ocean, and the ROV is driving all around it right now. And then this is the camera. This camera is pointing straight down, and it is taking pictures straight down. We have a second camera. This is the one, if you watch the live stream, this is the one you'll be looking at. This is called the Zeus, and it's looking straight out and getting the pictures that you'll be seeing. And then of course, the manipulators. These are super amazing, and not all ROVs have them. And these are the ones where you can actually go down and grab samples. And these are the samples that we've been collecting that Merlin will be IDing and telling us what we see. And some of the species, some of the things we're collecting have never been seen before. They're a new species to science. So it's super important that we actually get a sample of these and record them and learn about them. If I have another picture of the ROV here. Oh, that's a close-up of the camera. And here is the ROV going in the water. It's not a very, it's quite large. It's like the small car. And here it is being lifted off the deck into the water.
Tammy, we actually have our first question coming in.
Okay.
Somebody wants to know what ROV stands for.
Okay, that's great. Thank you for asking that. So ROV is a remotely operated vehicle. So that's a perfect question to ask right now, because how do we have to remotely, like on a line. So I'm gonna go back one picture. This remotely operated vehicle it sends a message up this cable all the way to this van. And so I'm gonna go over to the next page. So this is the control van. There's in this room down here is where all the pilots are for the ROV, which takes 3 people to pilot. And then there's also a science team in there directing what we would like done. So in this control room right now, we have a pilot. This is Rudy, one of our team in there right now. And beside Rudy is Jesse. And Jesse is controlling the manipulators in the arms, whereas Rudy's actually piloting the ROV. And in the far corner, we have a navigator that has to actually move the ROV, help move the ship. You have to control the ship to follow the ROV or the remotely operated vehicle around the ocean. And then we have a science team. That's Sheree. There's Dr. Sheree Dupree. She's also organizing and coordinating the science being collected. Oh, I'm going to pass to Skiljat, and she's going to talk about life on the ship.
Wonderful. And I'm just going to take this moment as we're transitioning. You may notice a little bit of a pause. That is because these folks really are out at sea. And so we are taking the time just to make sure that our communications go back and forth. And you can also see them putting their masks on and taking them off. That is to keep everybody safe, because of course it's a new world these days. So Skiljata, the floor is yours. Can you tell us what's it like on the ship?
Yeah, Hawa, it was a rough first few days as we, speeded up north as fast as we could. And there was some swell and we were really feeling it. I thought I would be tough. I grew up on Haida, but I still got a little seasick. But it's been great. Like everyone, it's a really great crew, the science crew and the Coast Guard crew. The meals are amazing that we have in the mess hall, like 3-course meals 3 times a day, plus baked goods any time of day you want. So they kind of keep you going if you need a little boost. Coffee always, which is a big deal for scientists. We run on coffee. Yeah, so we kind of get to be social between all the hard and exciting work that we do. Yeah, and there's a ping pong table in the lounge that we haven't tried yet, but we should definitely try in rough seas and have a blast and take videos and make fools of ourselves, because that's always fun. So these are our bunks. They're actually really, really nice. It's like a big upgrade from BC Ferries. Plenty of room to work, and we got bunk beds that we're sharing and little couches in our room. So we're riding style. We got a gym, we got a sauna, we got the canteen where we can buy chips and candy and t-shirts that say, John P. Tully on it. And yeah, it's a blast living on board. And yeah, it's a really great team. You got to meet a few people that aren't currently busy working, and all the different cool things that we do to understand the ocean better, from the teeniest of tiniest particles in the ocean all the way up to the currents and the big animals living, and all the different ways that we look at them so we can understand more. And I didn't really explain my role because I'm kind of jumping in on all the different sections to learn more about all of it, which has been really exciting for me. I'm mainly helping out with sample collections. So I'm trying to figure out who these animals are, who are they related to, do they have close relatives on the coast, or are they unique to the deep sea, and that kind of thing. So it's been really exciting. We've got a brittle star and a sea cucumber and potentially a sponge in the ROV right now that we're going to bring up as soon as it's done diving. So with that, I think we're ready for your questions. How everyone?
Awesome. I'm actually going to ask Mr. Williams if he's able, if he could share the story of SGaan Kinghlas. I hope I've said that correctly. And yes, that's a great segue. Just a reminder to everyone, when you're looking at your Zoom, we've got our lovely presenter along the bottom. You've got mute, stop video, and then you've got Q&A. So don't be shy. Put questions in the Q&A. Otherwise, you have to have my questions, which I tell you, those are boring. But let me give the floor to Mr. Williams.
Good evening to you all, or it's afternoon. Excuse me. So this story is from a time that SGaan Kinghlas was above water. So this story is really ancient. And we is CHN and our school system, we wanted to create a song for the children of this story. And there was some incredible master carvers that created masks for them too, that were puffin bird masks. So this story starts with 2 chiefs, one from Haida and one from the mainland. And they had this constant feud, this war going on between each other. And during one of those raids they were doing on each other in a battle, this one chief, he lost his wife. And this one chief was very wealthy. He had literally everything you could ever ask for. And he was loved by everybody. But during one of those battles, his wife was killed because with the Haidas, the ladies were right beside us when it was time for battle and war. Once that happened, he went into a deep, deep depression at the loss of his wife. And he started losing all of his wealth. He didn't take care of his home. He didn't take care of himself. He didn't take care of his children or the rest of his family. And he had a son and a daughter. And the daughter and the son both knew of parts of this story of a secret island that was shrouded in fog always. And very few people have ever found it. And so they went to each place they could to get information from the people of their village. And all these little pieces added up to a destination that they wanted to go to. While they were telling all these stories in between, they were getting their canoes ready to sneak away. And their whole purpose of this was to find this island. This island shrouded in fog, very few have ever found. It is said to be covered with puffin beaks. And those are really valued treasure still to this day for cultural people on the coast. And they're very difficult to find. As they gathered all of the information they could, they got their canoe ready, they prepared themselves, and then they finally went on their journey, taking off early in the morning. As they take off, it's very nice. They're paddling and they're paddling. And remembering all these things that everybody in the village was telling them. All the information they gathered and all the knowledge they gathered from being on the water. They keep going forward and forward into the seas, and it starts getting rougher and they keep going. And in the nighttime, after so many days, they heard in the darkness a sound, and then the sound kept getting louder and louder and louder. And it sounded like more and more people. It sounded like a whole hall full of people talking excitedly. And they just keep going because their determination to find this island pushes them forward. Dawn comes forward and they look and it becomes foggy. And they're still going along. All of a sudden, out of the fog comes a bird and it grabs the girl's hat and it flies off in this direction. So they keep paddling on, they keep going. And every time they started doubting themselves as they paddle, the bird would come and it kept going and going. Then it came into the night again. And again, loud, it just sounded like so many people excitedly talking away. And it just kept getting louder and they just keep going again and they kept going. And again, the bird comes and it flies over holding her hat. So they knew it was the same bird. And again, they keep following it and that the noise gets louder and louder as they're going through the night. And then they're paddling and then all of a sudden the canoe hits something. And as the girl put her foot out to check, the bird flies over again and she put her foot down and it touches, she could feel solid rock. And as soon as she put her foot out, it cleared up and all the noise they heard was all the puffins, all the birds making noise, all excitedly talking. They had found the magical island, the secret island. Excitedly, they get out of the canoe, scurrying about, gathering all they could, filling up the boxes that were emptied, that carried their water and their food, filling the canoe as much as they possibly could. and excitedly going back to their canoes and filling it up and talking of the happiness that they are going to save their family's wealth. Because in their father's depression, as I said before, he lost track of everything and he forgot about his family. But the children took it upon themselves on how they were going to save their family and make their father happy again. It's their turn, they paddle for home. And again, once they leave that island, the fog engulfs them and they go forward. With us on the coast, we learn how to go in the fog without machinery, radar, by the wind direction, by the waves. Even as a young child myself, my grandfather and my father, they would put their hand in the water as we're leaving and they check the wind direction, and then we'd leave in this crazy fog and we would find our way these in the places we wanted to fish. We would never hit anything. And so that's where that ability of reading the water comes in. All of that comes in with traveling and how to get somewhere safely and in the direction and in the time. As they head home, they're just going on, paddling and paddling, getting excited. And then in each village on the coast, there's always watchmen. And somebody seeing this canoe coming, this tiny little dot, it's coming closer and closer and closer. And then they start recognizing the canoe and they get excited. They thought it looked familiar. It looked like the canoe from their family of the children. And it gets closer and closer and they see that it is the children. They excitedly go to call the father and he comes down. He gets all excited and happy and embracing his children and coming forth. They gathered all these and they said, we gathered this for you so you could find your happiness and your wealth again. And none of that meant nothing to him, because in the end he realized that we cannot lose track of ourself and our family when we lose one family member. There is so much more people depending on us, and that we all look out for each other. Once they brought this here, this being the beaks, they had a big feast and distributed all that wealth to everybody. Because in our way, giving is more important than gathering. The only time we're gathering is preparing for a feast so we can give it away. We don't value things like, I love this. There's no word for I love an object. There's only a word for I love you. And that's Dundee Coylan. And so as they did this, the feast was done. The father was really apologizing to the children on how he was reacting to the loss of their mother. Almost every story that we have comes from a history of people passing it on. And each one of them has a bit of a lesson in it. And the one in this one is to not forget the rest of your family when you're in your grief. It's not always easy to do, but that's a story of that. And while I'm here, I'll do that. The song was created by Claude Jones with the help of the children. I'm just a messenger. And the words are, we are seeking Puffin Bird Island, then we will celebrate potluck. Oh, yo, oh, oh, yo, oh. the song created. And don't drink cold water before you sing. And so thank you for giving me time. And this is a story of our history of SGaan Kinghlas when it was above water. And again, it was full of life even then, for the birds to be there the way they were in the numbers they were. And all these areas are so important to all of us, as is the ocean and understanding them. So there's much appreciation for all that you are doing out there for us to understand the amazing beauty that is down there, and that it ties in with the history of the people here. And I thank you for doing that for all of us. And thank you for listening and giving me time to share. Hawa.
Thank you very much. It's wonderful to have you share with us. So thank you as well. And again, every time I hear that, I get goosebumps. It's wonderful.
You're welcome.
I am going to pass it back to Skiljada on the ship, because I can see that she is waiting and ready, and maybe this is a great opportunity. What creatures have you seen in the last couple of days, hours, and maybe even minutes?
Hawa, I just first want to say Hawa to Vern for the song and the story. It's really powerful to have that sung aloud while we're here. It was really nice. So I'm a little bit emotional. I'm not like in the mindset of like cool creatures. But Newt along Kengang, we saw an octopus earlier today. So that was really neat. I forget how far deep down it was. I'm trying to remember all the cool things. The sea pig yesterday was really neat that we collected. We have some good photos. Maybe we can pull it up real quick. It's a type of sea cucumber. It's real squishy looking, but it's got a bunch of legs. So that was a really cool find. I hadn't seen one before. And then we got to get up close and personal with it, as well as all the cool zooplankton. They're always really neat to me because they're kind of the foundation for all of the life. You know, the whales eat them, the birds eat them, the fish eat them. They're really special. So yeah, Hawa. Should I pass it off to someone else for a favorite sea creature we've seen so far? Where are you going? She's running away? Okay.
Too many wonderful choices. Oh, hold on. You got to introduce yourself first. We haven't seen you yet.
Oh, yeah, I've been in the van. I had the pleasure of flying for a lot today with the pilots and exploring. My name is Dr. Charisse Dupree. I'm one of the lead scientists on the expedition. I take care of the deep sea science. So I've been in my element and in the virtual control room all day. And I think the question is, what's your favorite animal that you've seen so far? I'd say my favorite so far is actually the sites that we just left. So we are revisiting sites that we've seen before. We went there 4 years ago. And we are in a place where there is almost no oxygen in the water. So you would think that life can't thrive here. And instead, on this amazing volcano out in the middle of the ocean, we are seeing such a high diversity of corals and sponges. And so we've been revisiting this area and zooming into these corals and seeing the exact same brittle star sitting on the exact same branch, on the exact same coral, on the exact same rock, on the exact same volcano 4 years later. It is incredible how long-lived these animals are, and the entire ecosystem right now, Cheat is my favorite animals. So I can't choose just one. I think it's incredible that they're all where we left them 4 years ago.
Awesome. Thank you, Charisse.
Yeah.
Do we have another favorite species someone else wants to share?
Yes, we have Lindsay.
Awesome.
Hi, I'm Lindsay Clark. I'm a grad student at the University of Victoria. What was the question? What are our favorite species we've seen so far? Yeah, okay. I'm not sure if this was said yet, but my favorite was the spot lobster that we brought up early on during our test dives in Saanich Inlet. I've seen them in photographs a lot, but never in person, so that was really fun. Anyone else?
Okay, so mine actually wasn't under the water, which is kind of rare for me. But my favorite was the albatross. Now, they are the funniest birds. They're massive and they skim right along the top of the water. And to land, they put out their feet like they're gonna like breaking on the water. They're really fun. That was my favorite creature so far. I had a good time watching them. Is there any other questions, or you want us to bring some more people through?
Actually, we have a follow-up question, and it is, how do we know how old an animal is? So Charisse mentioned that these animals are hanging out for 4 years. How do we know how long they might be there?
Merlin. Oh, that's you.
So very patient scientists have revisited the same sites and spied on the same corals and sponges over and over again for at sometimes decades, and they measure the growth of these animals. And so the cold water corals and sponges that thrive on SGaan Kinghlas-Bowie Seamount have been measured at a growth rate averaging 1 centimeter, just 1 centimeter per year. So when we find a coral that's 4 meters, we know that animal has been living there and thriving under these conditions for 400 years. So that is the non-invasive, very conservation way of knowing how old something is down there, is to revisit it, leave it as it is, and measure how much it grows. There are also studies you can do where you can take snippets of them, and I know that you can age some corals like you would age trees, but we tend not to do that in areas like this because it's about conservation. So we'd rather just watch the corals and take note of how fast they grow. And I'll say that it was very apparent to all of us when we revisited the sites today that we probably have new documentation on dozens of species, because we're seeing the exact same animal sitting there over 4 years. And so this would have just been unknown to science, that that particular species lives at least 4 years. And so maybe when we come back in 4 years time, we'll have to up that number to this species lives at least 8 years. So it's really neat that our science and observations we're making are going to contribute to that question. How old are these animals? How long have they been alive? Tammy just mentioned that from some fisheries data, because there was a fisheries on SGaan Kinghlas, we know that from the otolith, the bone inside of a fish's ear, we know that some of the fish that live on SGaan Kinghlas can be 205 years of age. So it's not just the things that live on the seafloor that are really old. It's not just the corals and sponges, but the rockfish too can be incredibly old. That's like 5 generations of your family old for one rockfish.
Wow, that is amazing that they can live that long when left to their own devices. Here's a
Yes,
question related
they like
to
it
this.
that way.
I can relate to that, I think. Why is taxonomy important in understanding these creatures? Why do they need a taxonomic name?
That is a great question. I could answer it, but I feel like others in the room could do it more justice. So I'm going to awkwardly pause to try bring those others on board.
And maybe you could talk a bit about what is taxonomy, or just define that word for a younger audience.
Right. Nobody is snatching the microphone away from me. Okay, wait. No, we've coaxed someone else in.
The game of chicken. I caved. So taxonomy, just means figuring out what the animal's scientific name is and where it is in the big family tree of all animals. So they have different categories of who they're related to, kind of like how you have your siblings and then you have your cousins, and you know, you've got like really distant relatives, like in some of our clan systems, we're related to like everybody in Old Masset, but you're more closely related to some people than others. It's the same kind of thing with the animals. So we have genus and species, which is like the two main ones. When you're talking about an animal, you're usually talking about the genus and species. Trying to think of an easy example that a species people might know. I'll just say the squat lobster because it's coming to mind. It's Monida quadrispina. So if there are other relatives, it might be Monida something else. So those would be closely related. And then the further up you go, it's related to other certain types of special crabs. And then you go more distantly related, it's related to crabs like Dungeness, and it's distantly related to shrimps because they're all kind of under that umbrella of decapods, which is a type of crustacean, and crustaceans are, you know, a big group. So you've got insects in the crustaceans, and then you've got all different categories of animals. Mollusks is a really interesting example. Mollusks are, you know, snails and octopus and clams and all these animals that look really different, but they kind of evolved from the same common ancestor. So they all kind of have something in common, even if they look really different on the outside. They're specially adapted to certain environments. So they get really specialized to their certain habitat that they hang out at, and they evolve specific strategies that help them out. So it's a little bit complicated to explain, but really we're just trying to figure out how related all these different things are to each other. So if we find a new species, we're like, okay, it looks really similar to the other species, but it's different enough that it might warrant a new category. So I hope that kind of helps explain it and I didn't just make it more complicated. But yeah,
I
we're
was
trying to
following
figure out
along.
the relationships of all the animals. Okay, cool.
That makes
My
sense, I
best
think.
guess.
Yes.
Anyone else can jump in.
Well, and actually, this is a great segue because you do have everybody jumping in. And so the question is, how do you become a scientist? It sounds like there are lots of different types of scientists. Can you tell us more about that?
Absolutely. I can kind of speak to the marine biology oceanography side of things, and then we can have everyone else jump in with their areas of expertise. Yeah, you can take a lot of different paths into winding up on cool expeditions like this, or like there's a bunch of different things you can do in science, and then even within kind of marine science, there's a lot that you can do. I studied zooplankton and juvenile salmon diets when I was at school at UBC. It was really difficult to get into the sciences growing up in the village of Old Masset, just because there weren't a lot of examples of other Haida scientists growing up. There was a lot of amazing, knowledgeable role models, of course. You know, my mom protect the forests, and she taught me to care for nature and to be really curious and respect all the creatures in the land and the sea and that kind of thing. But I didn't think I could be a scientist. And so university was really difficult. You know, Vancouver is a big, scary place. But I kind of toughed it out because I loved the ocean so much. And I had the support that I needed to kind of get me through those tough times. And I really wanted to do exciting trips like this. I was watching the 2018 expedition that Giselle Juice was a part of, and I got really excited with the idea that I could potentially do that. So it kind of helped motivate me to keep going when school was really hard. And yeah, just finding mentors that support you is like the number one advice. Is just like find someone who's done it before that can be an example for you. Ask them questions. You know, people are always happy to pass on knowledge. Yeah, that's kind of my route anyways. I'll let someone else jump in. Hawa.
Thank you for sharing. That is good advice, that it might be hard, but you can do it.
Hi, everyone. So I'm still actually trying to figure that out myself because I'm still a student. I'm in graduate school now, so I'm able to do some of these really cool things, like come out on this expedition. But generally, what I've been doing so far is I've just been following my interests, particularly in ocean sciences. So when I was younger, I actually grew up in Ontario, which doesn't have an ocean in sight. And so I would always just take the choices that got me closer to being at an ocean and took the classes. Once you get into higher grades in high school and university, then you're able to start choosing what classes and what topics that you're interested in. And you just keep choosing those until eventually you end up in the job that you're really excited about. And yeah, that's all the advice I have for right now, and I'll pass it off.
Hi, everybody. My name is Georgia, and I am a physical scientist. So I study usually what's on land and not what's on the water, but we're all part of the team here, and I play a role working with the data and building some of the 3D models that I think Tammy talked about. When I think about how I got here, there was a lot of school. If I started when I was the same age as some of you, grade 1, I went to school for 24 years, and that's a long time, but it was really enjoyable. And I think the biggest piece of advice that I have is to just stay curious, always asking questions. Yeah, having mentors. I think Skojala talked about that, having people that you can kind of just sit and observe and listen and sponge up knowledge from. And just, yeah, always stay curious and keep following your dreams. And I think I'm going to pass up to Lindsay here.
Hi, so I am doing marine biology, and in particular, I'm looking at all the critters that are on the seafloor. And, you know, a big thing is we all do a lot of school to get here. And, you know, not all of us do really well, but that's okay. As long as you keep pushing through, you keep trying, and you find what you're good at. And it might not be what you started with. I started really wanting to look at whales, and that was where I was going to go. But you know what? I found other things to love and other things to follow. And yeah, it's just all about keeping pushing through and finding what you like to do. I think I am going to pass this off to Tammy.
Hello. I actually am Tammy video. So I do the video on board, all the recording for and streaming out that you guys watch when you go onto the website. I initially went to school as a marine biologist, and then I got a video degree. So then I thought I wanted to combine them. I either thought I was going to work in a lab and just do research, or I was going to work on major documentaries for science, in ocean type documentaries like Discovery Channel and all that. And here now I do kind of both in a way, but none at the same time. So just be open to what interests you at the time, and don't be afraid to explore and push yourself. And you're not going to know everything right away, but that's what intrigues. And I think that's what drives probably most scientists to really dig in and find, you know, the what does what or why it's one way or the other. So that's all part of being a scientist of all sorts. You can see we have all sorts on board, and yeah, it's just the drive to want to know more and or why. My favorite question is asked why, but why? Even when you're an adult. And yeah, one more. Yeah.
Hi again. Okay, so I already introduced myself. So I'm a doctor and a professor of deep sea exploration, and my journey started off with being a surfer and not being that good at school, but I knew I loved the ocean, and the way I like to see the world was through video. And I just combined that love for the ocean and this way of seeing the world through video, and it made everything worth it. All the hard times in high school and university, and then grad school afterwards and postdocs, I enjoyed all of it. And so I was able to push through the hard stuff because it was the place I loved, the ocean, and it was playing with film. And so now, my job is I get to sail the oceans using submersible vehicles to film the deep sea, the open ocean. And that's how I got here. And I won't lie, it was a lot of hard work, but you really got to enjoy the process because you got to lean into that when it gets really hard.
Wonderful answers. Definitely reminding us that perseverance is always better than just plain old, skill. You just got to keep going. Unfortunately, though, it is the end of our broadcast. It is 2:45, and I know that as much as I would like to keep going, we probably cannot. I know folks have got places to be, and I know that you are pulling up the coolest things on your dive. What I'll do is invite, if anybody has an opportunity to stay for 2 or 3 or 10 more minutes, we can do that. But let's just officially just wrap up. Thank you everyone for contributing today, for joining us, for engaging. My colleague Kaylin will throw in the chat there the websites you can visit, the different places you can go to continue the adventure with this group as they are out at sea for quite a few more days. But yes, just a big thank you to everyone. Can I have a big wave from everybody there? Woohoo!
Bye.
Awesome. What a good looking bunch, I tell you. All righty. So we do have 2 more questions, just if there's someone who wants to stick around just as we are clearing out. And so the question is, why do we need to take pictures of the seafloor?
Yeah. The expert.
Hi. So one of the reasons why we take photos is so that we can go back at a later time and look at the photos in more detail so that we don't have to catch everything in the moment when we're watching the video out here. We get a second chance to look and, see what species was which. And another thing that I use the images for is that I build maps and models with them. And so I can take all the images that we collect as we're flying along, taking video, and I can put them into one big image so we can see the whole area at the same time. And that's really valuable tool for us so that we can start to analyze the area and do some science looking at what's changed, what's new. And so the images are really important for those 2 purposes. I don't think we have anybody else.
Still a great answer. Kaylin's going to give us the very last question, and then we will, just as people are heading their way out. And again, thanks everybody, and thanks for these great answers. I always learn something new.
Awesome. Yeah. Okay. So our very last question, we have, how old is the seamount? And maybe you could also explain briefly what is a seamount.
I'm going to get Charisse in here for this one.
Ah, yes, the seamount expert. Awesome.
It's amazing. Skilled Haida, myself, and some other co-authors just wrote 160 pages on this seamount, and the exact number is escaping my mind right now. That means 1.7 million years ago. So it's an old volcano. It's an ancient volcano. We believe that about 10,000 years ago, it was actually an island. So it would have only become, officially a seamount, I'm going to say recently, in the last several thousand years. But the volcano itself is in the millions of years old. And a seamount is an underwater mountain, usually volcanic in nature, and it rises at least 1 kilometer above the abyssal floor surrounding it. And by definition, it's not allowed to break the surface, or it's an island like Hawaii. And a really cool factoid is that all volcanic islands will one day erode back into the sea, once again becoming a seamount. And if you don't believe me, or you want to know more about seamounts, you should watch the short at the beginning of the Moana film called The Lava. And it does an awesome job of showing how seamounts grow as volcanoes under the sea and become volcanic islands.
Hey, gotta love accuracy in animated movies. That's awesome. All righty.
It's great
Yep.
science.
Why not? And we'll wrap up there. Thank you, everyone. You can follow us at #Pacific Seamounts on social media, all the social medias. You can find the expedition on the expedition website where you can use Slido to ask pictures. And thank you again, everyone. Have a good afternoon,
Aloha.
everybody.
Bye.
Good party.
Yeah. Good.